Hey guys, me Keith, Elder Rock, back on the bench. So I've been doing a lot of filming. I'm not sure how I'm gonna put this video together for this Defender board. But so I've got it all hooked up and I have a green screen. And at first I thought it was a sync issue. So this is an early version Defender board, and it does not have C-Sync. So I actually built a little converter board. That was my first rendition, and this is my second rendition, and that uses 74 LS 86. It's an exclusive OR gate, so it works. This one works too, but the sync isn't so stable. But with this one, refined, have a nice stable sync. So I know it's not a sync issue, and I also know it's not a RGB issue. I made a special test harness that goes red, green, blue, horizontal, and vertical sync. This is for Robotron later versions. This will be a C-Sync on later version William board. But for now, I'm just using this setup. So I just fired up the scope. I want to show you guys some stuff. Let's see if I can pull the print. Actually, I'm going to take you over. I got the print pulled here. So looking at this green circuit, have a transistor, 4403, NPN transistor. I pulled him, he's okay, and started kind of lifting some of these resistors and measuring around here. And then when I got here, things look kind of funny. Output here is okay. On these 89s are okay. But when I get here, I have a signal that's pulled low. Let's see, I'm going to probe that out and show you what it looks like. I'm not sure that's my problem, but it looks kind of funny. Without my blueprint here. Sorry, I'm going to try to hold this very carefully. Okay, so we have resistor 17 and resistor 20. So kind of looking at the map here. Resistor 17, resistor 20. Oh, we actually got D3, D4 first. These guys. And then they kind of connect to the R17 and R20. So let's go over here. I mean R16, excuse me. Okay, so let's go R16. I want to show you the signal. Wait. R16, okay. Where's the messed up one? R20. Let's see. Probing around until I find it for you guys. So these are actually Schottky diodes, or like a rectifier, and I just picked some up at the store. So at the market here in small village, Thailand. Oh, where are you, bad signal? Sorry, we can. I think this is the one. Okay, so that is R16. That is R16. So he's looking a little funny compared to the others. So these are like the other color resistors in this array, or in this area, I should say. And that is D7. That is D7. So yeah, he's looking a little funny too. D7. Yeah, I don't like that signal. I don't like those signals kind of pulled low there. See, it's not going high. not going high like the other ones. This is like 5 volts, and we're barely getting a volt. So I think I'm going to start with this guy. So he's actually R16. So if we look at that over here, R16 and D7 right here. So if we probe back on this L07 on this guy, we'll see that his signal is okay. Okay, so let's go just to kind of show the output of this guy. So it goes here, here to this guy, and then on the other side of this, Schottky diode, things get a little bit funny. So between here, let's see, the Schottky diode to, okay, I'm looking at the print over there, D7 to R16, here to here. So from here to here, things get a little bit funny. But on the other side of this resistor, things kind of look okay. But I'm not sure. Maybe we'll flip the board around. I already inspected the other side for shorts. Maybe I'll flip him around again. I got too much stuff cabled up to kind of do it on camera. So just wanted to give you a quick rundown of where we are on this board. Some troubleshooting. You know, that's the thing about the arcade laboratories. I want to do troubleshooting with you guys. Okay, so that's where we are. Thanks. Hey everybody. Okay, so we're back. When I left you guys last time, what were we doing? We had the green screen, and I wanted to check all of the circuitry in the green section. So I got it all printed out now. So just kind of what I've done off camera, I've went through. Okay, so here we have the red, green, and blue circuits. So since I checked all the transistors. I checked the control transistor. They're all turning on. They are all properly running, and I took them all out, tested them out of circuit. They're good to go. I checked all of these resistors, and even up in the blanking area, I checked, like I said, I checked this resistor, these controls. I checked the read-writes for these. So kind of getting into it a little bit deeper, I'm going to show you guys what I found just kind of probing around and thinking about this for a minute. Okay, so these are color RAM. These are the color RAMs. So they're not really using a PROM, but they're using color RAMs to select the different colors coming off the serial port. Let's see, serial port and data bus. So there's kind of like a shift, and there's kind of like a shift register. So basically, through the shift registers, it comes in 4 bits, creates 8 bits, chooses the color. So I'm guessing this game is 256 different color selections. Kind of keep that simple. Okay, so I was probing around on the outputs, and I set my scope up for volt average. So let's check. I might just throw it up. I think I'm just going to throw up the print on when I edit the video. Okay, so follow along. We're just going to check the outputs of the color RAMs. So let's just I can tell you already, these are all good. These are all good. No fishiness. Nothing funny coming in on the MPU address buses, from the shift register bus, from the decoder, enables, and all that. All of that's good. So let's just look at color RAM outputs. I'm going to show you guys some funniness. Okay, so let's just keep in mind. Okay, so let's just go. Let's go 5. Let's see. 1, 2, 3, 4. Oh, 1, 2, 3, 4, 5. Okay, so we have an inverted signal, call it 3-ish, 3.5 volts. And let's just do 5 on the other one. Same thing. I just reset the game. Maybe the colors are still okay. They're still kind of. So this is 7. Look at that. Let's do 7 on. Well, I gotta wait till the game starts playing again. Well, you can kind of see. Okay, now the game's playing. Okay, so this is pin 7 of this guy. And check out our voltage, 3.5 volts. So let's go to pin 7. Look at the average voltage of that output on that color RAM. It is not great at all. It's way less than a volt, and it should be like 3. So let's check the other ones. So we'll go the pin 9 output on one color RAM, 3.5-ish volts, 3.5-ish volts, 9, 10, 11, 3.5-ish volts, 9, 10, 11, 3.5-ish volts. So let's go back to, I think, is the bad. So I think this guy right here is causing us the trouble with our green. His voltage is really low. And then, you know, coming back through, if I start probing all the way back through this whole circuit, kind of get back up to here, the red, green, and blue transistors. Let's do... Now there is the... Crap. This is green. You see the voltage. Red. So I think we got some weird amplification stuff going on with the transistor. By the time that gets down here, and then the base voltage is 0.5 volt off from the other guy. So this is blue, just peaking out over 3 volts, back to green, and barely 2.5. So I think that happens because it's trying to amplify a little bit down here. So let's cut off camera again. I'm going to take this guy out and put it in the retro chip tester. What do you think? Is it going to be good or bad? We'll see.